Okay, solving the causal sine equation. Let's imagine we've got the equation cos theta plus 22 is equal to, what am I going to say, 0.5. I'm going to do it like 0.5 because I want to make the answers a bit nice. Now, in fact, I'm going to make that 1, change it, and make that a 2 then. Now this is quite interesting. We're going to have to do the inverse cos at some point, but at the minute the cos bit has got a 2 attached outside it. Okay, this theta plus 22, this bit here, that's inside the cos. So we can't do it. We can't take away 22 from both sides because it's kind of locked together in that cos. That 2, however, is outside. We can get rid of that quite simply by dividing by 2 to both sides. So we end up with cos theta plus 22 is equal to a half. Okay. Now we still don't be tempted to suddenly say, okay, we just take away 22 there, because that's what we do on both sides, because the 22 is locked inside that cos. The only way we can get rid of that plus 22 is by doing the inverse cos first. Okay, so theta plus 22 is equal to the inverse cos, arc cos is another way of doing it. Cos minus 1, arc cos. Okay, so theta plus 22, now if we did that in our calculator, it seems obvious that we're dealing with degrees here because 22 is way too big for to be used for radians. The inverse cos of 0.5 is 60 degrees. Okay. Now, as soon as we've done the inverse cos, we have to realise we're going to get an infinite number of solutions here. So if we sketch the graph, now the cos bucket starts at 1, that's at 90, 180, 270, 360. Okay, so there's 90, there's 180, 270, and 360. Now, 60 is here. That is one solution. However, we're also going to get this solution here. Okay. Now, we need from symmetry, the distance from there to there is 60. This solution is going to be 360 minus 60. So this solution here is going to be 300. Okay. So our solutions for when we inverse cos of a half are 60 and 300, and there could be a lot more. To get the other ones, it's quite simple. We just add on 360 to these two values. So another one would be 360 plus 60, 420. 360 plus 300, 660. Okay, these are some other solutions. But unlikely to be asked for unless they give you a range. I have to give them a range here. Okay. Now, theta plus 22 is equal to 60, 300, 420, 660. So theta has to be equal to, now we've unlocked the plus 22, we can take away 22 for all of these. Okay. So 60 take away 22 is going to be 38. 300 take away 22 is 278. 420 take away 22 is 398. 660 take away 22 is 638. And these are your solutions. Okay? The important thing is, you can, if there's something in the brackets, you cannot do that until you've got written down your entire list of solutions. Okay? Similar for a one like this. Sine 2x is equal to 0.4. Now, if we do the inverse sine, we get that 2x is equal to, the inverse sine of 0.4 is going to be decimal. Inverse sine of 0.4 is going to be 23.6. But we also know it's going to be other solutions as well. Now, if we look at the sine graph is a bit different. Starts at 0, it's the sine wave. There's 23.6. 23.6, we know our other solution is going to be 180 minus 23.6, which is 156.4. And then we can undo that dividing by 2, that times it by 2. Okay, so we can divide that by 2 to get 78.2, and 23.6 divided by 2 is 11.8. Okay, write the list down, then do the undoing of the bit in the